And now, the moment you've all been waiting for, I'm now going to give you the integral rules. Now, of course, this isn't all of them. This is just the ones that we are familiar with up to this point. Now, some of these you've probably figured out already. Okay, for example, this one with x to a power, you've probably already figured out that you add 1 to the power, and then you put a fraction in front that's the inverse of that. Okay, and so it shouldn't be too bad. These are the rules, just like the rules that we had with our derivatives. Now keep in mind, these things over here on the right are the properties. The properties will not be given to you ever on an exam, on a quiz, on the IB. None of those will include the properties. They will include the rules, but the properties are things that you should just know. So let's take each of these four and see if we can solve them. So the first one, we're going to apply the fourth property here, which allows us to take a polynomial or take functions that are separated by a plus or minus and break it up into individual pieces. So this is going to be the integral of x to the fourth dx minus the integral of x squared dx minus the integral of x dx plus the integral of 2 dx. Now, if we go ahead and look at our integral rules here, x to the n becomes x to the n plus 1 over n plus 1. So the x to the fourth will become x to the 4 plus 1, which is 5, and then over 5, or times 1/5, obviously. And then we'll have the same thing here, so it'll be x to the third over 3 minus x, that's the first power, so we'll add 1, so x squared over 2, and then of course when we got this plus 2, now 2 is a constant, and so it's going to be the constant times x. You could think of that if you want as an x to the 0 that you're adding 1 to. So there we go, plus 2x. Now of course at the end I have to have a c. Now you'll notice that I didn't write c for every single one of these integrals. The reason being is that we don't have to, because each one of these will have a constant, but when you add constants together, you just get a constant in the end. And so we just need one c, even though they could all technically be different. In the end, there's only one constant once we put them all together and simplify. All right, so let's go ahead and look at the second one. The integral of the square root of x plus e to the x. And so we're going to rewrite this as the integral of x to the 1/2 dx plus the integral of e to the x dx. And so you should be able to figure those out pretty easily. This one is going to be x, we're going to add 1, or 2 over 2. So that'll be to the 3 over 2 over 3 over 2, or times the reciprocal, right? Which makes sense, because if we took the derivative, the 3 over 2 would come to the front, cancel out, subtract 1 to 1/2. But we're following our rule here, just like this. Okay, plus the integral of e to the x, which is e to the x. And then, of course, we always have to add the plus c on at the end. Okay, so that was easy enough. Let's move on to the next one. Okay, so here we go. We now have the integral. Let's go ahead and break them apart again. We're using this fourth rule quite a bit, but that fourth property is very helpful. So we're going to rewrite this one actually first. We'll go, before we split it up, we'll go ahead and rewrite this. This is 1 over x to the 3 over 2. Now we know that we can rewrite that as the integral of x to the negative 3 over 2 dx plus the integral of 4 over x dx. Okay, now we can recognize that this 4 is a constant, and the constant, as we noted in the sixth integral property, the constant, that 4, can be pulled out. And so I'm just going to rewrite this as the integral of x to the negative 3 over 2 dx plus 4 times the integral of 1 over x dx. Now from this point we can go ahead and follow the integral rules. So I've got x to the n power here, so I need to add 1, which will end up giving me, I guess I don't need the integral sign anymore. So we'll have x to the negative 1/2, but then we have to divide by 1/2 or multiply by the reciprocal, so negative 2 over 1. So that's my over n plus 1, right, over negative 1/2, which is the same thing as times negative 2, and then plus 4 times the integral of 1 over x. The integral of 1 over x, we see right here in the rules, is the natural log of x, and of course plus c. And so if you want, you can simplify this a little bit more. We can go negative 2 over the square root of x plus 4 natural log of x plus c. All right, so you can see that these aren't that difficult. It's just figuring out how to put them together using the rules. Now this last one is probably the most difficult of the bunch, and so let's go ahead and do it. We've got 2x minus 1 over root x. Now you may recognize this as being something, when we did the derivative, this would have to be a quotient rule, right? We would have something on the top and something on the bottom. Well, technically it doesn't have to be a quotient rule. We can do something to it. We can change it up. So that's what we're going to do, because we don't have a quotient rule for integrals. In fact, we don't have anything that's going to help us out with this. So what we're going to do is we're going to rewrite it as the integral of 2x over the square root of x minus 1 over the square root of x, and then the dx at the end. So I haven't actually used any integral rules yet. All I've done is separated this so that it's two different fractions. Now from this point I will separate it into two integrals using that fourth property. So I'll write it, and actually I'll take this 2 and I'll bring the 2 in front as well according to that sixth property. So I'll rewrite it as 2 integral. Now x over root x is x to the first over x to the 1/2, which is x to the 1/2 dx, minus, and then this is of course x to the negative 1/2 minus the integral of x to the negative 1/2 dx. And so now we can go ahead and take the derivative of each of those. And so by breaking it up into individual fractions, it now became something that we can work with, whereas this one right here would be a little bit more difficult to do an integral for directly. So we'll go ahead, we'll write down 2 times, now x to the 1/2 will become x to the 3 over 2, divided by 3 over 2, which is the same thing as times 2 over 3, minus, and then here it's going to be x to the negative 1/2 if I add 1 to that, because I'm still using this same rule, the x to the n. So x to the negative 1/2 plus 1 would become x to the 1/2, and then I've got to divide by n plus 1. So I've got to divide by 1/2, which is the same thing as multiplying by 2 over 1. And so then we can put it all together. We've got 4 over 3 x to the 3 over 2 minus 2x to the 1/2. And if you want to rewrite those as roots, you can, or you can just leave it as is. All right, so there you go. We've got an introduction to using the integral rules. Now, of course, this wouldn't be complete if we didn't write it properly as 4/3 x to the 3 over 2 minus 2x to the 1/2, and then we got to add on that c at the end. Don't ever forget that c when you're writing an indefinite integral. All right, go try some on your own.